Okay, so tonight we have Dr. Emily Stanley and Dr. Randy Hunt. I'm going to introduce Emily first. And Emily hails from Connecticut, right?
Originally?
Originally, a long time ago.
No, not so long time ago.
Still what?
Emily is a professor of zoology at UW-Madison. Like I said, she grew up in Connecticut. She went to Yale, and then she went on to grad school in Texas and Arizona. She's named to the list of Madison's 50 people most likely to make a difference. She is a rabid Red Sox fan, but she's been in Wisconsin long enough to become a Packer fan too. Emily's interested in many aspects of water-related science, including chemistry and biology of streams, lakes, and wetlands. Now, a little story about Emily. Emily, being a good wetland scientist, often goes to bogs. And we have an instrument for sampling bogs. And you know what a bog is like. It's really gushy and soggy and wet. And this instrument is about a 2-foot-long chunk of steel. And you have to drive it into the bog. And in order to do that, you have to attach it to a long pole. And then after you attach it, you take this pole and you shove it into the ground really hard. And then you have to give it a twist, and then you pull it back up. Now, if you haven't done this quite right, you pull up the pole, and you pull up the pole only, and you have left the giant chunk of steel down in the bog. And so when this happens, we say that you have temporarily stored the peat core, which means you have to go out and get a shovel and dig it out, which is quite a job. So, how many times do you think Emily...
7!
Once.
No, I'm only going to give you a 1,
One too many.
2, or 3.
1. 3.
What do they think about you, Emily? She only did it once. If she had gone to UW, she wouldn't have done it at all, though. Okay. Now I'm going to say a few words about Randy. Randy Hunt is a research hydrologist with the U.S. Geological Survey. He completed his master's and PhD at University of Wisconsin-Madison, where he is also adjunct professor in the Department of Geosciences. His research focuses on investigating groundwater flow and its effects on natural resources, including wetlands, streams, lakes, and ecological systems. Okay, so Randy has been in Wisconsin a long time, so which of the following is not true about Randy? His grandfather owned a grocery store in Minocqua during the Depression. A. B. His first truck, a beat-up 1975 flatbed Chevy, came from Minocqua. C. He met Jim Peck of Jim Peck's Wildwood fame, who was a friend of his dad's. Or D. He's the great-nephew, on his mother's side, of John Dillinger. What do you think? D, that's trite. It is not true that he is no relation to John Dillinger, although I'm sure he wishes he were. Okay, so here is Randy Hunt.
Thank you very much, Susan. I would have to say that having a grandfather who owned a grocery store in the Depression was actually better. That was better to be a grocery store owner during the Depression than Dillinger, I think, actually. And it was amazing to go see the people that would stop him on the street as we'd walk through and thanking him for the loans that he gave during the Depression and paying them back a little bit at a time all those years. And that always has been kind of a high bar to go match. So this is my giving back to the North in that way. I do hail from the United States Geological Survey, where we have no regulatory or enforcement capabilities or desires. We're generally the science arm of the U.S. government. But I hail from the Wisconsin part of it. And this Wisconsin Water Science Center is really notable because Wisconsin really hits above its weight when it comes to water, not just in the U.S. Geological Survey, but in the world. And it turns out the person that actually organized and was the first chief hydrologist, the first water scientist, was Luna Leopold, which is the eldest son of Aldo. And what's really interesting is that when you think about Wisconsin, it kind of permeates in a lot of different ways. Water in Wisconsin is that out of all of the National Academy of Science, there's only one family that has 3 siblings in the National Academy of Sciences. And they're Luna, Starker, and Estella. So you're looking at just that particular aspect is notable. No other state has done that anywhere. In addition, this particular state, for my area of water, every big name in the 1800s and early 1900s touched Wisconsin. We had the very first people who did groundwater back in the 1870s was Thomas Chamberlain. And he was actually a president at the university, but he was actually contracted by the USGS to actually do this work. And he said back then, which is kind of an interesting thing now, is that it is well understood, this is 1870 now, as well understood that our water does not come from Canada, and we can just put that to rest. And then we had Ham's Brewery that came back in the 1970s and kind of shot that down. In addition, we had one of the other big names was one of the early professors who done in my area this work of groundwater was Schlichter, Charles Sumner Schlichter, and he was here in the 1800s, 1890s, and he was another professor from UW, but he was actually contracted by the USGS. And as well, Mainzer, O.E. Mainzer is the father of groundwater. He came from Beloit University. You have here some of the earliest limnologists, Burgeon Jude, working up here in the 1920s. This is stuff that is not done anywhere else in the world. And so when you look at it, Wisconsin hits above its weight in water issues. So hailing from Wisconsin is really a good thing when you come from the hydrogeology background. Now, we're known as the Badger State. The Badger State is essentially because of our geology, not so much because of our water. It's because of the miners, the lead zinc miners down in the southwestern part of the state. They looked like badgers coming out of the holes where they were mining. But actually what we're also known for is being the beer brewing and the earliest beer brewing capital of the world. And it's really interesting, why here? Why here? I mean, it's not like there weren't good Germans and Poles and Czechs brewing all over the place. Why here? It's really interesting. If you wanted to brew a lot of beer, what you need is a lot of water. And so that you have a lot of water, but how do you get a lot of water out of the ground? Well, in the 1800s, you didn't have the big pumps or electricity that we have now. So what they could do in the Milwaukee and the La Crosse area is that they could just drill into the ground and the water came up itself. It's artesian, and not just a little water, it's a world-class aquifer. Lots of water, lots and lots of water. So the brewers had as much water as they needed in these areas, very specific areas, low next to surface water features, but they could just drill in the ground and get all the water that they needed. Now, the interesting thing now is that same area of Milwaukee that used to have water going somewhere between feet above the land surface when you drilled into it, now has water levels down around 300 feet below land surface because of that focus on our water. When we talk about water, it's actually not as mysterious as it often seems. So I often go and, in my old life, I liked to do wiring with my dad. We actually wired some places up here, but when I was wiring, you would run into the plumbers, and as you know, there's always a friendly rivalry between the plumbers and the electricians. And they said, "Oh, you electricians, that's way too hard. For being a plumber, you only have to know one thing: water flows downhill." And I thought, well, that is much easier than electricity. But then I was thinking about, I told this story, saying, because in my area, groundwater, it's exactly the same thing. Water goes from high to low, and there's no mystery there. You have a low spot in the land, there'll be water coming out. Where is that water coming from? Well, it's coming from uphill. Well then, so I give this talk to a convention of plumbers in La Crosse, and they got really mad at me and said, "You say that there's only one rule to being a plumber. That's not true. There's a lot more to being a plumber. There's actually 2 rules." And I said, "2 rules?" He said, "Yes. So whenever you say that, remember, hot is on the left." So now I am finally able to plumb as well as do electricity. But this idea, where does the water come from and where does it go? It's actually not that hard. Okay, so water flows downhill. You've got the plumber's rule, and then you've got what I call Scotty's rule from Star Trek. I can't change the laws of physics, Captain. It's like your bank account. What comes in goes out, and what is, if you put out more than you go in, it goes down. And I can't change the laws of physics. The water has mass balance. What comes in has to go out. And if it stays there, it's stored there, and that storage is like holding, like in your bank account, to be tapped sometime else. Well, with these two laws, you can pretty much explain how water moves through this landscape. And so a lot of our work is because you can't see a lot of the groundwaters that we actually simulated on the computer. But this idea where water moves actually goes back to Aristotle. The idea, where does the water in the rivers come from? Even when it doesn't rain, there's water in the rivers. How can this be? So even back then, they were thinking about what are the things that, what makes this water move? So from this idea of water, just to start our conversation, because I actually want to go spend more time talking than hearing you talk than me talking, is this idea of the misconceptions of water. And I'm going to throw them out, and this actually comes from a student of Aldo Leopold that I actually had on my committee, a man named Jim Zimmerman. And he had a knack for reducing very complex things down to very nice statements. And he had 4 misconceptions of water, of wetlands, and I've taken them out to waters and waters of Wisconsin. Now I've taken them, part of this book, and I've left a copy here with Tom, but this comes from a National Wisconsin Academy of Sciences forum from 2002, which actually Luna Leopold was our honorary chairman. But it was from this transactions, but there were, and I've written them up in here. But just so you have something to go mull over and we can talk about, this idea that waters are all alike. Whether I have groundwater, whether I have surface water, whether I have water that's from Nakusa versus Ashland. And the difference is that's actually not true. And a beer brewer would know this, is that you can have the barley and the malt and the hops, but the water is actually a very important ingredient. And if you have a Pilsner Urquell or a certain beer that is noted, the water is incredibly important. And the Czech beer, the Pilsner Urquell, is driven as much by the hard water. They have dolomites and stuff, so the water is very, very hard, unlike your water here, which is very, very soft. They have very, very hard water, and the taste of the beer is actually driven by that water. So that's an example of, no, the water actually makes a difference, and some things are really tuned for that water. Second thing, that we have all the water that we could possibly use. The thing about water is that if you look at it along in its time frame, everything, this water here has been through a dinosaur's kidney a number of times. I mean, when you're talking about this scale of time, but the problem is, as they often say, in the long term, we're all dead. Is that eventually there's a time scale and a space scale that's different. And water, if you look at it long enough in space scale, it's true. Wisconsin has a lot of water. If I took all the water that fell on the state, there'd be more, and we could give stuff to Arizona, and we could give it all you want. But the problem with water is not perfectly transportable. If I have a lot of water in Hayward, that doesn't mean that I can get that water down to Waukesha. And so the problem with water is that the timing and the spatial distribution is not perfectly transportable. And so that you can have shortages of water even in a water-rich state like Wisconsin. Those aren't shortage for the state, it's a local shortage. But even in Wisconsin, you can have areas where there are shortage. Finally, that water has a memory. The fact that what we see in our landscape is not necessarily what we're doing right now. In many cases, the water moves very slow in the ground. In a year, it might move this far or this far. So what you're seeing when you say, oh, the nitrates are going up in the Central Sand Plains, that's not necessarily what's being applied right now. It actually could be what be applied in the 50s and the 60s. The 70s, that there's a lag because the groundwater system goes on its own time scale, and so you have this mixing of water. So down in Madison, for example, what we do is that if you go into Dane County, half the water has nitrates that are too high to drink in the private wells. And yet you don't hear that from the municipal wells. And why is it? Well, that's because the municipal wells are deep. Okay, yeah, thanks. Okay, well, I appreciate that. And so ultimately, why are they doing this? Well, they're pumping deep because that water was put in by the glaciers and before people started actively hitting the landscape hard. So it doesn't take much to go think about if you're putting in water on top of the ground of your drinking water supply that you can't drink and you're pulling from the deep part that you can, there's a certain point that that's going to give. And so that there is this idea that what we do on the landscape, the water does reflect this. And so my favorite quote along this line actually comes from Luna Leopold, which I had a pleasure to meet a number of times over the course of my career. But this is one that is widely attributed to him, and so we asked him flat out. I was with Kurt Miney, who's the biographer of Aldo, and we asked Luna straight out and said, "Did you say this quote? It is so good, and everyone says you said it, but we can't find it." And he looked there, he got this sly smile and said, "Sounds like me." Well, here's the quote that if it isn't his, it sounds like him. "Water is the most critical resource issue of our lifetime and our children's. The health of our waters is the principal measure of how we live on the land." And with that, I'll go give Emily her shake at it.
So how long should I go? Okay, all right. So thanks, Randy. It's a little bit of a tough act to follow there, covering everything from plumbers to Aristotle. I am not quite sure where we're going to go with this, but I do want to reiterate that it is true that Wisconsin really does hit above its weight when it comes to water. This is, I feel tremendously honored and fortunate to have the opportunity to be a limnologist in Wisconsin. And by the way, that is a word that everybody in this room, how many of you guys know that word? All right, so if you don't know what limnology means, it is the study of inland waters. So I tell people it's like oceanography, but for lakes and rivers. And Wisconsin is actually the epicenter of modern limnology, or North American limnology, largely due to those folks that Randy mentioned, Burge and Judet. They were professors at Madison, and they had a field site up here, just up the road at Trout Lake Station. And I think they indentured servants, students, to come help them in the summer. But it's a great place to study because this Northwoods area is one of the most lake-dense places in the world. And it really is a fantastic laboratory to study lakes. There's this huge diversity. And if you really want to know why lakes are different from one another, or what causes things to happen here, this is the place to be. And it's a great tradition and has had this long legacy. And because things started with Burge and Judet, there are a number of things, a number of lakes we've been studying and have these tremendous records that go back to the turn of the 20th century and 19th century about lake chemistry, lake ice duration, and things like that, where we really can begin to get this new perspective on long-term changes in these lakes around here, and it's fantastic. I think another thing I can emphasize here, because we're in a brewery and Randy has brought up the all-important topic of water and beer, something near and dear to my heart. And yes, I am a Red Sox fan, but I've warmed a lot to the Brewers, greatest logo in baseball. And this, to me, here is not only a lovely beverage, but it is one of the very useful teaching props that I use when I teach limnology. So Lakeland folks, there'll be a quiz on this in the morning. This is one of the things that is remarkable to me about the Northwoods, is well encompassed in this beer. One is that, as Randy said, the water quality is really important to the quality of beer. You just absolutely have to have good water to have good beer. Actually, the very first time I came to Wisconsin, I was driving through in college. We took a tour of the Schlitz factory. That tells you how old I am. And I hadn't had Schlitz in a while, for obvious reasons. And they gave us a tour. They're saying, this really, we take such care with this water. The water quality is excellent. We clean it up. We monitor it so closely. And we really have honed our craft to have this delicious beer. And I was really thinking, oh, I should have given this beer a better chance. Maybe it's quite good. And had the tour, and they gave us a sample. And nope, same old Schlitz.
Water only goes so far.
Yeah, that's right. That's the water only goes so far. There are some other things that are very important. And one of the reasons why beer is such a great teaching tool is the other things that make the beer go even further, which is the things that give it the lovely colors and the fizziness. It's really all about carbon, as it turns out. The fizziness is from carbon dioxide in there, and we know that lakes are a place where you can get some carbon dioxide produced. But it's really the lovely colors that you get out of the beer that are fantastic. It's from organic carbon. It's like your cup of coffee or your cup of tea, where plant material is leached out to give things these awesome flavors. And the lakes around here are also colored a lot like beer. They don't taste quite as good as the beer yet. But this is one of these things too, as you can see, one of the Northwoods lake secrets too is that they are great places to store carbon. With all the lakes and wetlands, we are a great repository of carbon in those peatlands. And I want to confess, the only reason I only stuck the core in once was they wouldn't let me use it again. Someone learned their lesson, let's just say. But yeah, so this is also not only a water-rich landscape, but it is a carbon-rich landscape. And a part of that is all the water here. As Randy told me the first time I think I went out and do field work with him, is that lakes and streams and wetlands are just places where you can see the groundwater here. I'm sure he isn't biased at all. But these really are fantastic ecosystems because of what they can do. They're unusual because in most parts of the world, most of the carbon is stored above ground in trees and plants, and here it's really stored below grounds in wetlands and lakes. So it's really sort of a treasure that we have along with the great recreational opportunities of the water. So yeah, and the water quality here is really pretty remarkable. I mean, in southern Wisconsin, because of the legacy of farming, we have a little bit of a problem with our water quality, as it turns out. That legacy does not exist here, and there's been a moderately good job at sort of keeping the waters very clean and nutrient-free. Having problems with eutrophication really haven't happened here, and hopefully that'll be something that will go forward into the future. And I think at this point, given where we are, I may just stop so we can open it up for conversation, if that's okay.
That's great. We're going to take questions now. We're going to have a mic circulating. Just raise your hand and Carol will bring it around. You guys will share this.
You sort of hinted on it in your first presentation. Where do our waters come from? And secondly, where are our lakes going?
Well, that's a good, you see, I can tell you where they're not coming from is Canada. The idea of the underground river is a very nice, but it's just not physically. So where is it coming from? It's coming from very close to, especially up here, very close to where you see it. When your well, where is that water coming from? It's very close to your well. In this way, it empowers you in that you have a say over what happens to your water. Unlike places in southern Wisconsin, the area that the water comes from is many miles away from where the people who are seeing the bad effects are. And there's a disconnect. In this part of the state, your water comes from the areas right around that you see there. I mean, it can be, you know, for example, Trout Lake, you see Crystal Lake. Some of the water there goes all the way down to trout, but not a lot of it. A lot of it gets picked up by the other lakes, and so a lot of these flow systems are pretty close, and the groundwater, and it moves up here. It moves relatively fast. Like down we have water that's glacial water, 10,000 years old. The water in Trout Lake is probably the oldest. Is probably going to be around 200 years old or something like that. So it's moving a little bit faster than a lot of the other systems. Thing about you have up north here is that you have incredibly good aquifer, really good water, but you've only got one. So. As Fred Madison, a friend of mine, a professor from UW Extension, a soil scientist, in his salty way had said, the thing about up north is if you fudge up your water, you're fudged. In the south, we can dig deeper, and there's glacial water to be had. Here you have 100 to 200 feet of good sand and gravel, and then you have bedrock that doesn't give much water. So that ultimately where your water is coming from is all around you and you have control over it, but that's all you're going to have. Where your lakes are going, that one is, that's a lot bigger story. The lakes have a memory. The residence time of a lake, it doesn't reflect what happened last year or the year before. It integrates years before it. And so where it's going, actually some of it depends on where the lake is, its position in the landscape. Oh, sorry, it just seems like I'm so loud here. But
It's you.
I'm from, yeah. Yeah, so ultimately, I think that where the lakes are going is really going to be variable. It's also going to be driven primarily by what you do around the lakes. Just like where the water comes from for your well is near, what the lakes respond to are what you're doing next to the lakes. And so, for example, there's a lake where I grew up. We have a cranberry bog on it. Everybody wants to say it's the cranberry bog is made the lake more eutrophic. Well, it's also the fact that they are near Minneapolis, and they have gone and developed every single 100-foot lot on that lake and put green lawns down to the lake. Oh, okay, there is a bog that's been there since I was a kid, probably has been there since the 40s or 30s, and the lake was quite fine. The bog is still in operation in the same way, and now the problem with the lake isn't the bog. The bog has been there a long time. But as where the lakes are going, actually I'm going to go refer this to my limnology, Center for Limnology professor, and she can give you a better answer.
No, that was a pretty good answer there. But I mean, the water quality here is very good across the board, and I think, I mean, it's a future of the lakes. The issues that challenge keeping that good water quality are, it is about some of the nutrients and things coming off of lawns and so forth. But I think, to me, one of the bigger issues, of course, is the invasive species issue that is going on with a lot of the lakes here, sort of managing those. And I know that was the topic of another Science on Tap. It's probably the biggest thing in terms of the future good health of the lakes around here is who's showing up and who's sticking around.
Could you comment on what I call water mining for bottled water and the effect on the aquifer of this massive trend of ours?
Well, yeah, it's a great for the purposes of pushing you out of the box a little bit. They say, isn't it amazing that if Perrier made beer, would there have been near the outcry when they wanted to go near the McCann Springs? And so the idea of moving water and I mean, the thing, what you're pointing out is that bottled water is 100% consumptive. That water is removed and does not go back, especially as it's trucked away and it moves out of the watershed. A lot of times if you drink your water out of your tap, you have a septic field, the water goes back in the system, and the larger system doesn't see much difference for the water volume. The thing about pumping water out, and whether it goes into beer and gets shipped out upstate or it's bottled water, that water does not return back into its watershed. And just like your bank account, if you keep overdrawing that, it will go down over time. On the other hand, I mean, for me, it's amazing to me that your taps generally have better water than most bottled water. And yet there is a real mismatch of perception versus actual quality. I mean, there's been any number of studies showing that bottled water doesn't have great quality, but your taps are tested quite a bit. Here you have some of the best water in the world. The idea of a bottled water here is an odd one to me. So I think there's a lot more to it. It does amaze me the amount of resources, and water and energy is a very tightly, and this is the easiest thing I've ever had to explain to my in-laws. They say, what do you mean water and energy? Water's water, energy's energy. I said, have you ever filled a 5-gallon bucket and carried it up steps? Go and imagine now carrying it up 100 steps. That's what these wells are doing. That takes a lot of energy to go do. So there's many questions involved in that, the reusable resources, but certainly the water part of it is interesting, because in our culture it's interesting that water is priced, and this is Robert Glennon had pointed this out. It's like going to a gas station and saying, I'm going to pay you for your rent and the electricity and the infrastructure, but I'm not going to pay you for the gas. So that's how we price water, is essentially we say, I'm going to pay for the pipes and I'll pay for the electricity to pump it, but the water itself has no value. And that's a very odd feature for something that is so critical for economic health and supply.
Any questions up here?
I'm from east Wisconsin. How does our long-term water, not along the lakeshore, but away from the lakeshore, how does that compare to up north there?
Harder water, you've got more calcium, magnesium, you've got the carbonate rocks. You have some of the best, you have really good springs, Scuppernong and that kind of area are really good springs. You have trout water. You also have springs that have gone dry because of the pumping. There's a fair amount of urban pressure down there. And again, one of the biggest water users is Waukesha. And the big difference for using waters, whether you use the lake water or not, is whether you're in the watershed of the lake. And so just outside of the lake's watershed is a very high pressure of high population. And so that a lot of your water, your springs, there, many of them have dried up, unlike the springs here, which are still functioning. And in fact, we have in Madison, we have a pagoda from 1917 showing this, and it says on there that the children play in the spring water, and it hasn't flown for 60 years. And so there is these areas of pressure where you're pumping a lot of water. Again, Wisconsin has lots of water, but if you pump a lot locally, and where a lot of people are, those water resources will be tapped. And I would say now probably the biggest, one of the world's largest impacts on the groundwater system that we can see is the Kona Depression that starts up in the Fox Valleys and goes all the way south of Chicago. Now, it's underground, you don't see it, but it's kind of an invisible thing by the springs drying and the streams having less flow and that kind of thing. Less people up here, less pressure, less water pumped, so the systems here are generally more water rich than down south, but you have some local places, and some of the springs are as good as any place in the world down in the southeast.
When you have a marsh that feeds a lake, what effect does mismanagement or management of that marsh have on the lake?
Well, the answer to many of these questions are it depends, of course, sort of how big is the lake and how big is the marsh. But a lot of times those marshes that ring lakes play a really important role as acting as buffers that will catch things as they move from the upland areas into the lakes. Certainly in the southern part of the state, those fringing wetland areas are incredibly important to protecting the lakes. Around here, what a lot of those things those marshes provide is, again, is the organic carbon to the lake. That's what gives it those darkened colors a lot of times. And it turns out that that organic carbon in the lake plays a whole bunch of different roles. It shades the lake, it can affect the temperature of the lake and therefore how it stratifies. It can affect the growth rate of algae in there, and so it can ripple on and have an effect in terms of what the fish communities are. So if you're reducing the amount of that marsh area and how the water moves through the marsh area, you can really change the chemistry of the lake if you're persistent enough in doing that, and really shift who's there and what the nature of the production is of that lake. So it can actually show up in funny and surprising ways.
I probably stole this from somebody. What I often said, though, is that the wetlands are the kidneys of the landscape. And so ultimately that it may not look like much, but just like your kidney doesn't look like much when taken away out of the whole of your body, but it does an incredibly good function. And a lot of these wetlands are underappreciated for the fact that they are the kidney in the landscape. They're often in the low areas, and they're doing a lot of the processing of the heavy lifting before that lake sees the water.
Yeah, we hear a lot of talk about two things when it comes to water in the state of Wisconsin. Sand fracking in the western part of the state, and also central sands, high capacity wells. My questions are, number one, for sand fracking. There's some people that quote that it's hurting the water table, polluting the water table, and that kind of stuff. Does it or doesn't it? Is there any research? Because they never cite any statistics from any study. It's all newspaper stuff. Okay. The other one about central sands and high capacity wells. Now there's a lot more than there used to be high capacity wells. And if you live in Madison and you've driven up back and forth here in the last 30, 40 years, you can count them. and I think there's 20 or 30,000 now in that area. When it comes to that groundwater question, what do we do to fix that? So either of you, but
yeah. Well, I mean, the one thing is that we've certainly done some work, and I should say my colleague Mike Feenan at my office has really done the heavy lifting on this. But in Wisconsin, what we're seeing from the frack booming, what we're seeing in frack booming is not fracking itself. That's the stuff happening at the Marcus Shale and out east, and so it's actually the sand that we're pulling, and it's actually part of our geology. Is that we had a big period where a lot of our 400 million years ago, these rocks were deposited by wind. And so these sandstones have incredibly well-sorted, perfectly rounded sand, and the sand is ideal for fracking. And because what they do then is that in North Dakota or in Texas or Oklahoma, they go and they drill down and they have this new technology that they can go sideways. But there's all this pressure because the rock is heavy. So they need to go keep those pores open. So they put a lot of pressure in and then put the sand in. And that keeps the cracks open after they release the pressure that allows them to pump. Well, this sand is incredibly valuable, but sand it's amazing. If you looked at all the resources in Wisconsin that whether it be bottled water or anything else, our biggest resource that we've used out of the geologic spectrum is sand and gravel. Sand and gravel is very expensive to make, and the fact that they have all of this really good sand available in the bedrock from the southwestern part of the state is ideal. So the fracking problem here is not one of water per se, because most of our units, our rock units that they really like, are above the water table. So they're not going into the water. So the questions for fracking for Wisconsin are much more about traffic. I mean, I think it comes out to being a truck a minute at some of these places, 24/7, 365. So I mean, it's a fair amount of traffic. The air quality. So there's these other aspects to Wisconsin. But the actual water issue, because we're not fracking here, we're actually shipping the sand. Actually, one of the biggest problems now, which I just learned about, is that the fracking is backing up the agriculture because they're tying up all the train lines. And so you have all the agriculture there with the production of their fields sitting there and can't get out of the state because the rails are being tied up by, because they're at capacity and they're moving a lot of sand. Central Sand Plains, it's really a mystery to me, and I think this is a case where probably the UW maybe hasn't done its best work lately there, is back in the 1960s, a famous movie. In fact, you can go to the state survey with the Wisconsin Geologic and Natural History website, and you can see this movie made by the USGS back in 1960s. And essentially they put a well next to the Little Plover River. And they pumped that well like crazy. Not as big as a normal ag well, but it really pumped it hard, harder than your household well. And you can see the river go down. Okay, and then they did the opposite. They would go and put the water in the river and watch it lose. So you could see that the groundwater and the surface water were the same. So the idea that when you add more wells, you pump more, the fact that water levels go down has been long known. And why that is still being fought about now is a mystery to me. I'm not quite sure. As a scientist, I mean, I realize there's a lot of other economic and other issues there, but from the water end of things, it's very straightforward. Like your bank account. I can't change the laws of physics, Captain. The water, I only get so much water in. If I pump it out, it's just not going to be there. And so those questions there, you're exactly right. As the number of straws, I mean, this aquifer is like your milkshake, and the more straws you put in and they're all sucking, the faster that milkshake goes down. And there has been incredible, one of the huge changes that happened between the 40s, the 50s, and the 60s was the ability, which I learned also just recently, is actually because they had aluminum left over from the war and they wanted to have a use for it. And so irrigation pipe was one very good use for it. And so that the irrigation I mean, the reason that it expanded so much was in part due to the cheap aluminum. But it exploded. But between the 40s, 50s, 60s, and 70s, the number of wells, number of straws in our milkshake have gone way, way up. And at some point, it becomes a social issue because it's really not a science issue. It becomes, what's the highest use of water? What should water be priced at? Who gets what water and when? And those questions aren't science questions. Those are actually social questions.
This is kind of a related question. I guess several years ago it was reported that the Vilas County well, I guess the one that supplies most of the municipal water there, and their ability to test or access the water table level, it was considered to be at its 70-year low from the time they had started recording this data. I'm just wondering if 2 significant winters of long-time ice cover and significant increases in moisture were enough to stabilize this at all, or whether it's simply too short a period to have any effect.
Definitely helped. It definitely helped. You can look at it just like your bank account. It's supply. It's not only what you take out, but it was also going in. You had a couple of years up here where there was very little going in. And you saw it in the lakes, you saw it in the streams, and you certainly would see it in the well levels as well. So the idea that you're not in those dire dry periods, and the fact that you're having some going in, it definitely helps. But you also have the outflows as well, and that's what often people forget about, is that your sustainable water use is also what you're using as well as what you have coming in. Because the water is actually being used by everything. You know, you said there is no unused water, that the water, whether it goes out to a spring in an ecosystem or out to a rare plant or to a trout that you catch, to a lake that is kept clear because of the groundwater. I mean, the water is being used. And so the fact that you've had a lot of growth up here too. I don't know your water use records. I'm betting that Cheryl Buchwald across the hall from me would be able to tell me, but I'm guessing they're up a little bit. On the other hand, you're a very water-rich area. You're surrounded by lakes. So the fact is that unlike Wisconsin, the southeast Wisconsin, where they draw down hundreds of feet, Madison pulls out 55 million gallons a day, and it drops around 60 feet. And that's because they're pulling from the lakes. They don't have to, the water doesn't have to go down anymore. It can just pull from the lakes. So the fact that your well is in a lake-rich area is getting supplied by the lake as well.
So in the Pinocchio Hills, of course, there's talk of having a big mine out there, and there's a lot of strife between both the mine and the local residents. And I'm curious about how you feel that is definitely going to change their water quality, or is it not, and how that's going to change Lake Superior.
Oh.
I'm a government bureaucrat. I have no feelings.
Nice.
Oh yeah, okay. I mean, the thing is that there's I've gone and worked where, I mean, one of my first jobs for the survey was working on the Crandon mine. Again, there's science questions and then there's social questions. There's a fair amount of use that we use. We generate and we use a lot of resources from around the world, and a lot of these resources are coming from developing countries or something else. So the question at Crandon was, do you go and get your raw material from Bolivia, which has no rules at all, or do you get it from Wisconsin, where we have rules, and at least then we're also carrying some of the weight of our lifestyle? So the idea of mining itself, and I should say, I mean, I came in before I was a groundwater person. I was actually an economic geologist, just because I never was one. I wanted to be one. But I mean, the idea being that we're the Badger State because of mining. On the other hand, mining is really not that. You think water is straightforward. Mining is actually straightforward too, and it actually is very economic. And this is Ken Carlson, the vice president of Rio Tinto at the time, was telling me it's 10% return on investment. That's what it comes down to. And so the cost benefit, they have a certain cost, and then it's at what point does the society benefit enough to go do it? The thing is that's different from Crandon versus the Gogebic mine is that the Crandon was 1,600 feet drop in water table. It was a huge stress to the groundwater system, but it was only 100 feet wide, but a mile long. So it's really hard. That was a tougher problem. The Gogebic mine is in the old bedrock, around the Precambrian, so it's about 1 billion years old or a little bit less. they're complicated rocks. There's not much water in them in the big sense of what we consider economic volumes of water, but they feed other systems. They're in the headwaters of other systems. So we've done some recent work with the Bad River Tribe, trying to help them characterize, get a baseline for their water resources, and that report will be out in probably a month or two, and I'd be glad to go share that with you. But ultimately, the questions are, they're multifaceted, and science is only one part of it. And I'd be glad to go talk about the science, but a lot of the other stuff is I can see both sides, but I don't know what the answer is.
I have a quick question. In our newspaper, they recently talked about they've changed the rules on mitigation for development of wetland areas. Can you talk about that at all?
Yeah, I mean, my history. My history is actually, my PhD was actually in wetland mitigation and building wetlands, and I've seen both sides of it. Back then in the 90s, the 80s and 90s, what you had was that every place you filled in a wetland had to have the wetland next to it. But what this became is unmanageable for the DOT or developer to actually track over time. So there was an incredible amount of wetland mitigation done where they failed miserably, and nobody was tracking them. There wasn't the money to go invest to go watch them. So then came into saying, well, this is not working. What can we do about this? So the idea was, well, what we'll do is we'll have wetland mitigation banks, where we will go and find areas that are good for wetlands, and we'll put the resources and we'll build wetlands where there weren't before, and we'll monitor them and make sure they're functioning wetlands, and then we'll let a developer go and take care of a wetland here, versus I would go and buy credits in this wetland there. Wisconsin was not an early adopter of that, but wrote one of the more strenuous versions of that law. That would have been about 1994-ish. So the idea is a realistic, trying to balance out both sides. But the deal was then the only place you could buy those wetland credits was through a private entity or through a nonprofit organization. So the question now is whether the state can go and take, as I understand it, I should say this is in the regulatory end, which I can pontificate on, but I really don't know that well, but is that you can pay the state, the DNR. So it's in case of fees in lieu of, and you might have seen this on the local level. If you're in a bad spot to mitigate, you can pay money in lieu of trying to do something because it's not cost effective to do it here. The village board will do it somewhere else where it makes sense. So as I understand it, the theory is that this would be like a fees in lieu of, that you would pay the state, that would then go feed some of the programs that would help the overall wetland base over the statewide.
So I guess my follow-up question would be, is that feasible to do that? And is there the oversight to make sure that that is done?
So the question was, is it feasible, and is there the oversight to make sure that it's done? Feasible it's an interesting thing, because just like I said that Wisconsin doesn't have a water problem when you look at the whole state, but if you look at local areas, it does. There are some wetlands that I have walked through that I've never seen anywhere else in the world. That wetland, is it feasible to recreate that or mitigation bank it somewhere else? I'm thinking Burr Oak Swamp, outside of the Crandon site. No, that's not feasible for us to recreate that. But on a lot of these cases, they're reed canary grass, which is an invasive species. They're not very productive, and somebody wants to put their driveway through it. So the question is feasible is a moving question built on societal values. What are all wetlands the same, or are some better than others? What is the wetland doing a function? The problem is the wetlands is hard to go know their function, because a lot of the wetlands are only wet during part of the year and then dry the other. And so you don't think they're wetlands, but then they're clearly wetlands at other times. So partly the science hasn't caught up to the policy and to what society would like to go do. On the other hand, maybe we haven't researched them enough to go give better answers on the cost-benefit trade-offs, and that might be our fault as a scientist. As far as the oversight, I have no standing to go and say anything about it, because I don't walk in those moccasins. It's a tougher business.
Yeah, with 1,300 plus lakes or so in Vilas County, and I guess 19% wetlands, we're kind of a unique situation in the United States, certainly. I guess my question is, for the average lakefront property owner or the average lake association, of which there's about 90 in Vilas County, would there be any advice either of you would have other than the obvious aquatic invasives, shoreline runoff, shoreline buffers, for the average, what the average property owner can do or the average lake association on a local level to either maintain or in some cases improve water quality in the paradise we live in?
That is, yep. Excuse me. That's a very good question. It's given that water quality is in pretty good shape. I think the biggest thing that could be a source of nutrients to some of the lakes is in fact the yards that are of the property owners. There really isn't probably much of a need to fertilize them heavily, so I would certainly say back off on that and have some buffer. You don't necessarily need to mow right up to the edge of the lake. Another very simple thing that is actually very good for the more as a habitat thing is just leave the wood in the lake that falls in. I know it's tough on the boats when you come up to the dock, but a lot of times the very first thing folks will do is pull the wood out of the lake that is near their shoreline, but that we do know will directly reduce the growth rate of a lot of fishes that you want. A lot of the aquatic plants that my colleague Susan Knight is very famous for studying are often quite good habitat as well, and so yanking out some of the aquatic plants may not necessarily be a good idea either, and they're part of that kidney system that Randy was talking about that just sort of moves into the lake as well. So I think yeah, so that would be sort of my advice for these things. Yeah. Well. Yeah.
I would say keep your septic system in good repair.
Yeah, and yes, keep your yeah, that's a very right. Keep your septic system in good repair by all means. Yeah.
Yeah, water flows downhill, and and your lake is the low spot. Yes. So it's a pretty natural conduit. I would say the very good work done by Steve Greb and an old USGS, Steve Greb from the Wisconsin DNR. He was in the research branch, but there's a fact sheet out, and in it we kind of show here is the effect of lakeshore near land next to a lake. Because just like I said, your well gets water from nearby, and it reflects your land use next to your well, and the lake is the same way. And so the idea of the buffer strip is that we actually did some work showing the effect of the buffer strip. It's incredibly, even a small distance, so in this case even 10, 20 feet of buffer off that lake made a huge difference in what that lake saw, which I was very surprised at. The other thing is that definitely we make fun of people in Arizona with the green lawns and say, don't they realize they're in a desert? I've heard it said here, they make fun of us when you have that green lawn next to a lake and said, don't you realize you're in the North Woods? This is not what it looks like up here in the North Woods. And I would have to say those are levels of nutrients these lakes are not used to not used to seeing, and they're very hard to control. And so I'd say just the idea that the lakes don't need the fertilizer, but neither do your grass for the most part.
Thanks for sharing your expertise tonight. Can you talk a little bit about nitrates and high levels in some of the local wells, as well as private shallow wells?
Yeah, well, I mean, again, you have nitrate problem. Nitrate is a classic problem that's human-induced. It's not something that you're seeing as a result of the natural landscape. So it's normally related to septic failing or a heavy load. For example, In Brown County, there's 8,000 people and 80,000 cows. I mean, just the carrying capacity of the land and the fractured rock. So you don't have the brown water and stuff like that they have there. They have a lot tougher problem with nitrate than here. Here, I think you again would look for local sources and the fact that the water you drink is a lot of time in your control, or at least in your knowledge of what's going on. So if you have a local hotspot, there's probably something local that's causing it.
Hi there. Hi, I'm with the local Trout Unlimited chapter, and I was just playing around with the USGS's FishViz model, which is climate change model, that predicts kind of what the different species distribution will be in the next 50 to 100 years based on climate change impacts. And I know fisheries isn't your level of, or your area of expertise, but I'm wondering if you could speak on the issue of climate change and how we might mitigate it here in the Northwoods.
Well, you're not going to mitigate the climate change. But, so the question was, how might the changing climate affect the fisheries here, right? In the Northwoods in general, and what can be done to deal with the consequences of the climate change, right? So the changing climate is happening at obviously a much larger scale than we have local control over. But there's been a lot of interest in how the water bodies around here and across the state are going to respond, and there actually was a group that got together a few years ago and put together called WICCI, see if I can remember the acronym, Wisconsin Climate Change Initiative, and they talked about mitigation and adaptation responses to dealing with the climate changes and what might happen in 50 to 100 years. And there's a lot of very specific suggestions in there about how to adapt, sort of how to go with the flow of the changes, or how to mitigate them and try to reduce them. And some of those do relate to fisheries. There is some unfolding changes here that with the fisheries beyond the trout that have captured a lot of discussion having to do with the balance between walleye and bass that some people think the warming of the waters may be involved in. And I think, if these changes are happening at a large scale, we cannot change the temperature of the lakes. That's just, that is something that is out of our control. So perhaps one way to deal with it is enjoy bass fishing, but probably not the answer a lot of people want to hear. But there are some ways, though, certainly to protect headwater areas where you see a lot of the trout streams and things like that, to afford them protection, keep the riparian areas protected so that they can have some local thermal buffering is clearly one way to do that. And I mean, there's a whole bunch of different changes that are unfolding. I mean, obviously the ice duration is another big one where we are losing the length of time that these lakes are frozen over the winter. That's a mixed thing. There are some good things and bad things about that. But I think a lot of the changes will happen very slowly, and we will sort of naturally adapt to them without even realizing it in some fashion. But
yeah. There's a very local, actually from Vilas County up at the Trout Lake Station, I did a report just recently that you can get online. And it actually looks at the changing in temperature of the streams and the changing in flows. And what Emily said exactly right. It's uncertain, right? Because all these drivers are uncertain. It depends what people do. Do we keep doing business as usual? Do we go worse? Do we become smarter? And all those things are assumptions that actually drive what could happen to the climate. But all of the scenarios say it's going to get warmer. And so what you would find for our area is the change to the actual water flows themselves is pretty very hard to see anything meaningful. But the change in the temperature, because we know that is what every model agrees, it will get warmer. So your cold water habitats are going to be, they're going to have a harder time making a living. And so you can imagine, and in fact in this book, if you look at this, my old boss, along with John Magnuson, a professor from the UW here, longtime fixture up at Trout Lake Station, but they actually said it's not that hard to imagine in that you start looking, trading space for time. So what do you think this will look like in 100 years? Maybe look to the southern part of the state. What do you think in 100 years? Maybe look to the Ozarks. In that kind of view, as a wetlands person, the bogs, you're on the very edge of the bog distribution. Bogs are much more up north. You get to here and you get much south. So I would imagine looking into the future that the bogs are going to have a hard time making a living. Going into the future, and that will change how your landscape looks. And as far as the water, you'd say, well, the groundwater might mitigate this, the cold water. Well, the groundwater actually reflects the average air temperature. It's not magically cold. It's not a refrigerator. It's actually just reflecting the fact that we have cold winters and we have warm summers and our winters are cold. So we have this temperature. Most of the water comes when it gets into the groundwater while it's cold. Well, that change means that average air temperature is going to change. The temperature of the water going into the ground is going to rise. So even if the groundwater stayed exactly the same, that refuge that the groundwater provides now is going to be less because the water is going to be warmer. So it's going to be harder for cold water species to make a living. Now, on the other hand, we have a bog outside of Madison, a really nice bog. So there'll be pockets, I imagine, that would be resilient. But ultimately, it's going to look more like south and less like the UP.
Just wondering if you have any comments about the use of soil or water heat in a house. It's very easy for me to keep my garage above freezing by just putting a coil out into the local ground near a swamp.
I'm a fan. I mean, just by the fact that it's a renewable resource in that and especially, I mean, it's interesting that the Koreans, I reviewed a paper and they're actually tuning their systems that you can get to a certain depth where the lag of the heat and the cold is perfectly suited so that it's coldest in the ground during the time it's hottest at the land and vice versa. So their systems are much more efficient than the normal system that's built. You're taking advantage of the natural system in it, and if we could figure out ways to go harness the sun's heat, we wouldn't need the other force because we get a lot of energy from the sun. We're just kind of inefficient with how we use it. So I'm a very big fan of that. I also like the fact that you're saying I'm not going to go make it 80. It's the fact that I'm just trying to keep it from freezing, and that's a more friendly fit for the world when it's this cold outside and you want to be 80 in here. It takes more resources to go do that. So I think it is part of how living in where you live and finding a way to make it work.
Sorry, folks, we got a lot of people here. We're going to take just a real quick 3 to 5 minute break, and we'll be right back. So you get yourself another beverage if you like. And some of you I know might have to leave, but we'll be right back in 5 minutes. Okay, folks, we're going to get going. Whoa, that's loud. We're going to get going again. Finish getting another beverage for yourself, and we'll start to take some more questions. So think of your questions, raise your hand, and Carol will be around to hand you the mic. I'm sure everybody has at least one question that they can think of to ask. How do they grind up all that water?
Does it take a while to extricate?
Yes. Yeah, I know. Okay, think of those questions. Raise your hands. Okay.
Alrighty. I was going to come back to the idea you mentioned. What we do on the landscape is shown in the aquifer with a lag. How might the controlling of lake levels here in the Northwoods have that lag, or how might that be revealed in the groundwater?
That is a great question, and I would... Okay, the question is the idea that groundwater and the water system lags, and we can see that in the water quality. And then so what happens on the land shows up in the streams many years after it was applied on the landscape. How does that affect lake levels? And it's really interesting that The lake levels and the tie to climate is one of those things that we as scientists have had a hard time getting our head around, because when we arm wave someplace, somebody will point out a lake across the street where it doesn't do that at all. And so there is a difference between how a lake responds to a stress, like what you're doing next to it, or a drought, and how long it responds to recover, and also, I mean, what it takes to get hit and what it takes to recover, so that the lake has a setting that it's sitting. It's got its home where it's making a living, and some of those things it sees really fast, and some of the things it doesn't see very much. What I've learned now recently, I think there is a way that we can do this better, and one of the ways would be is that we would actually start tying in the lake itself, where the bank account of that lake, where it gets its water, how much of that comes from groundwater in the area. Because the groundwater moves at a slower rate than the climate does. And so I'm guessing if we started tying the lakes more formally into that groundwater contribution, because that amount of money into the bank comes in all the time, the climate either comes in or it doesn't, I think then we'd have a better feeling for it. We do know that the groundwater system, there are some streams in Wisconsin where even under the biggest drought we've had, they haven't gone, some of these trout streams have not decreased flow. And it's just one of those things. They must have a very big aquifer that's feeding them. But these are an area, because we can't see the aquifer very well, and so we're inferring a lot of it. But I think in the next 5 years, I'll be able to answer your question a lot better than I can right now.
So the question was, what about the effect of dams, and does that influence the lake level response to climate? To groundwater. Yeah. So dams can affect the relationship between surface water and groundwater, because you're backing up the surface water, you're piling it up, and that will exert some pressure on the groundwater table for sure. In the local, again, it affects the local bank account, to borrow Randy's wise words. Yeah, and so that may alter the speed, the lag between the response to any drawdown at the groundwater table that you get. I mean, usually what the dams do is they tend to raise up the local groundwater table. So for example, if you remove a dam, you can then see the groundwater table will slowly sort of discharge and go back to where it would have been if the dam had never been there, backing the water up.
Well, what about the ecological impact of those dams? Can you speak to that?
There are ecological effects of the dam. I mean, can you be more specific about, the heat? Well, you can certainly, yeah. I mean, if you build a dam and pile up the water behind it, one of the classic consequences is to increase the heat of the water upstream, and depending on how the dam is operated, you can see either warmer or colder water downstream. Yeah, I mean, that's a well-established consequence of impounding water, because you're giving it more chance to heat up, you're giving it more surface area to be exposed to warming.
There were quite a few places in the Minocqua area particularly that had problems with flooding in basements last spring and early summer. And we heard all kinds of stories about, well, the water table was so high, we got snow late, so much snow, and so there was so much melt. It was the ice on Lake Superior that was melting late and contributing, that the ground was frozen, so the water had no place to go. What's going on? How can we keep it from happening again?
No, 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 yes. The Lake Superior ice, and again, I'm very fond of painting with a broad brush, and but what happens to your basin is very much driven by what's happening around your house, and so the thing about frozen ground, if you said there is a frontier in science where we are not very good right now, is the physics of frozen ground. And I'll just give you the thought experiment. If we have snow, a big bunch of snow that comes in October, and it blankets the land and insulates it, and then it melts without ever melting during the rest of the year, it melts in the spring, the ground is wide open and ready to take all that water. if we get one of those Januaries where everything melts, and then we get that February that's colder than cold, and we have that ice like this, that ice melts from the top, but it's not melting down here. So all that water now, that same ground that would have taken the water super easy is now saying, I don't want none of this water. You're going overland into that basement. And so that frozen ground really controls how the winter affects your basement. When you say, what can you do? Clearly, there are some things you can do. The common ones that you hear about is mounding up, having a positive, having relief away from your house, sloping away from your house, watching your window wells. But I mean, those are the things that you already know about. When the groundwater floods, which can happen, where the water gets so wet that the groundwater comes up and starts filling basements, then you just get a sump pump. R2, and unfortunately there is no, at that point, that groundwater, that big bank account is giving you the money that you really don't want. And so that ultimately, in that case, you manage it locally. It isn't something that you manage on a larger scale. Clearly, lake ice and that kind of stuff is not the reason why. Lake Superior affects certainly near the lake, and I can show you some areas that lake effect snow is a real thing. But down here, no, that's not one of your major drivers.
Hi, I'd like to thank you for coming up today and sharing your expertise with us. You had mentioned that USGS has been working with Bad River Band on the hydrology of the reservation. Have you studied intensively the hydrology of the Pinocchi Mountains themselves, especially where GTAC would like to place their mine?
No, that's our charge is to help the tribe make a baseline and characterize their water resources. So to the effect of the water that flows into the tribe's lands, we've certainly looked at. There is a lot of that land is private land. So it's not something that the USGS can just access. And so no, I mean, we look at it from much more of the watershed perspective as saying, where is this water coming from? But the detailed work around the mine is all done by the company.
I see. So you have no part in modeling what will happen to people's wells in the surrounding area, or how much water is going to be inflowing into that great big pit that they want to dig.
There is a scenario of a dewatering situation in the area of the Gogebic mine, but it's not the mine per se, because there's a fair amount of local geology that controls how that's locally expressed. The local wells are generally downstream, they're downhill, and generally the problem for the local wells are probably going to be more of what you'd see in the Central Sands than you would see up there, is the fact that the declining water tables are easily addressed by just digging deeper wells. I think the problems that the tribe is worried about are much bigger than just the change in the water level caused by the pit. I mean, I think they're much more holistic over the landscape.
Oh, yeah.
But we're only part of their characterization. I mean, this is a lot of the stuff the tribe, their resources of the tribe are beyond water. For example, we were just talking earlier at dinner about their wild rice. It's, for the Great Lakes, it's unprecedented to have that kind of wild rice. But wild rice is, again, an area like frozen ground that we don't quite understand. Why is it here and not there? So there's many things that go into what the tribe is worried about, water being an important one, but it's only part of it.
Correct. Yeah, I'm of the understanding that the Kakagon Slough area is like 1/3 of the wetlands surrounding Lake Superior. I mean, it's huge, the effect of filtering surface water into that lake.
It's definitely huge, but I wouldn't say it's a third.
Okay. Okay. Thank you very much.
Yep.
Question?
Yeah, hey, so I guess just piggybacking off of the Gogebic mine question, what do we know about the effects of the mines in the Iron Range of northern Minnesota over the last, however long they've been 7,500 years, what effect they've had on their local waters and wetlands.
Yeah, you know, we've done some work for the Great Lakes Indian Fish and Wildlife Commission. Again, painting with a broad brush. If you're right next to the mine face, you would have seen things dry. If you are further from the mine face, you wouldn't see nearly as much. And different mines have different responses, so there's a fair amount of site-specific nature to it. I would have to say that the thing about the Iron Range is that was developed and was a major resource during a time that's different than now. The taconite, for example, that was being discharged into Silver Bay is of the same quality, as I understand it, as what we would be pulling out of the Gogebic. So it's just a different time, and so what was done there, so what we've learned there is saying it's not any different than any other groundwater, surface water problem anywhere in the world. The laws of physics, I can't change the laws of physics. If you draw down the water table, you will go and draw down water levels next to the mine. But we also know that it isn't affecting Canada. It isn't affecting here. Those are local effects caused by the mine, and partly some of the rock is really tight, and where the rock is tight, the effects are very little. Where the rock is more porous, then you see the effects further away. I don't know if that answers your question, but it's a broad question, and I could arm wave for quite a long time, as Emily will tell you, but I'll let somebody else ask a question too.
Anyone else?
Seeing how we're on the mine, I'm sure you're loving this. But maybe you could answer this on a geological thing. It's my understanding the White Pine Mine, we'll go on the other side, had some issues with salt or some old ocean water trapped underneath and leaching into Lake Superior. And the fact that they had to engineer around it and constantly pump water into the mine to prevent it from leaching. Maybe you could talk about what's underneath us and that situation.
Oh yeah, that's a great question. One of the things that I've actually surprised, my parents are from Ashland, so I know my cousin works for the waterworks there, and he's saying, you're a groundwater person, you can help us out here. We want Ashland, we are on lake water, but lake water is very hard for us because the lake water changes and Schwamigan Bay stirs up, and then we have to go clean all this water. It's a lot of regulation to make sure it's drinkable, and there's a lot of work, and it's a lot of expense, so we're gonna go to groundwater. But you know, we put in a well, and we got salt water. Now this is in Ashland now, this isn't near the mine, this is by Ashland. I said, it's too salty to go drink. So we put in a well somewhere else where we could get water that's fresh, but we couldn't get enough to feed the town. So what you're seeing there is that your geology, you have a box that you live in, and in their case, their box said you're not going to use groundwater. That salty water is there for hundreds of millions of years. We call that connate water, the water that's actually there during the rock's formation. So it can often be saltier than the actual ocean water. So that connate water can be that salty water can be very salty, but it's naturally occurring. It's been there since the rocks were made. So then ultimately that question of what do you do with that, normally you don't have to do anything because the system is well adapted to something that's been there for 300, 400 million years. It's okay with it there. The problem is when you perturb it and you start loading parts of the system with it, and for example, that if that water had to go through all the clay to Lake Superior, and it took hundreds of millions of years to get there, and all of a sudden you're pumping it out of the mine and into the lake, short-circuiting the natural system, now you have a different question. So the problem really is in a matter of the time scales, not so much that Lake Superior is an incredibly, I mean, it is a great lake in every which way you can go look at it. Salt water is definitely something you don't want there, but we also salt a lot of our roads. And so that ultimately, it's again a question of cost benefit. At what point do you do something about it? At what point is it important? And those are the kind of, a lot of these things I have no answers for. I'm not quite sure what that trade-off is.
I have a question for both of you, I suppose. I'm wondering, with research projects that you've done over time, something that you learned that was really surprising or novel to you?
Nothing, we know everything. No.
I would say it's not so much me, but the old timers. Oh, the question is, out of all the work that we've done, in fact, it's kind of embarrassing. We don't have something that rolls off our tongues. But I mean, out of our work, what is the stuff that is most surprising or interesting? And I would have to say that my work has been really built on the shoulders of people that came before me. And I mentioned Jim Zimmerman here, and some of what I've taken the fact of endangered or invasive species. And I said, I never saw why, that's natural, right? These things come in. And Jim Zimmerman pointed out that he has been studying an invasive reed canary grass patch for 40 years, and it hasn't moved. Okay, that means these invasive species don't just come and go. If they come in, and it's what he called king of the hill and musical chairs. If you're at the right time when the music stops and you're king of the hill and you're an invasive species, you know what? You're not moving. So that kind of idea that the system is dynamic except when it's not is a really interesting. It was a big surprise for me, because I thought everything's changing. It's always changing. Change is just part of life, and there are some things that once it flips, it's a threshold. And it's a tipping point. It doesn't come back. And that irreversible nature, I've learned this in groundwater. We have the same thing. In California, where you get a lot of your vegetables, is that they're pumping the heck out of the groundwater during the drought. Well, that's fine if you have wet years and dry years, but if you have dry years and you pump and you pump and you pump, that water actually gives pressure to hold up the ground, and the ground starts shrinking. Well, if the ground shrinks and compacts, that is irreversible. You've now mined the groundwater, and you'll never get that water back into the ground because it's collapsed. It can't, the skeletal support of the rock can't hold itself, and it sits. The idea that we could be irreversibly changing some of these major systems that are feeding big chunks of the U.S. it's a surprise to me. That I kept thinking that the system is so resilient, and that we were able to go, our ancestors were able to go do some pretty nasty things to the environment, and the environment bounced back. But this idea of a tipping point and a resiliency, and there's a spot that you can push it, that it won't come back, that's actually a surprise of some of the work that I've seen.
Okay, so I would say actually one of the things that has been a big surprise to me is having been convinced by Randy about the nature of hydrology around here, and that all the streams and lakes and wetlands are deeply connected to the groundwater, and really it is one resource, is having looked at a lot of the chemistry of the water here, is how quickly this one resource can shift in its identity from one location to another. If you leave a stream and get into a lake, how quickly the switch is thrown, that the chemistry changes and the nature of the water changes, or moving from a wetland into a stream. And it's just sort of the remarkable imprint of the local conditions and the local ecology enforcing, sort of throwing itself onto the water, that is just, it's such an enormous biological influence that we see here. That it surprised me, yeah.
I've got a question. Is water now the new gold or new oil? And if so, is Wisconsin going to be benefiting from that?
Well, I would say that's a great question, but yeah, I don't think it's the new gold or the new oil. I think we're coming to realize that's what it is. I mean, I think the example that Randy gave of California is a really good one. I mean, it's a little bit scary to me to see what's going on there with their groundwater, having gotten my PhD in Arizona, where water was brought to you kindness of the Rocky Mountains and not passed along to Mexico. It seemed to be a very valuable commodity there that was poorly priced relative to its its value. And, you know, we're seeing some remarkably interesting things unfolding in some parts of the world having to do with water. And water-rich places have always been targeted as an economic resource. I mean, you hear lots of very interesting plans that people have. My favorite has to be the towing the iceberg plan that crops up from time to time from Canada. Canada sees its water as a remarkable long-term resource that will become more and more valuable as demand for water increases and less of it is in the solid form. And there are places where, you know, water is extremely finite and is regulating the way people behave.
Yeah, I mean, I have to smile partly because I brought up the California example, but I can't tell you how much I like, maybe being a grocer's grandson, to have broccoli in December and January. Fresh broccoli and some of the vegetables that you get out of the Central Valley is actually something that's pretty amazing when you think about it. But what strikes me is there's a book called The Big Thirst, and it was actually given to me by the ex-chief of the Office of Groundwater. So for us, groundwater in the USGS, as high as you can get. And in this, it's a really interesting book, but he kind of points out that we're actually living in kind of a bubble where water has never been cheap, available, and clean. The idea of over human history that you've had cheap, available and clean water is just not something that was over the majority of our human species existence. And we've had this bubble of the last 100-some years where water is cheap, available, and clean. And so what's going to happen is that in the future it won't be all three. You'll have to go, they'll start having trade-offs between cheap, available, and free, and clean. And so that ultimately there is going to be the reuse, for example, the idea of, and I can remember this Water of Wisconsin's meeting, and a representative from one of the tribes says, I don't understand how we can even talk about this when we're flushing drinking water. People in the world are not drinking good water as what we flush. And yet that sanitation system of flushing waste has been one of the major advances of your longer life health and a healthier existence and longer life expectancy. So I see these trade-offs are there all the time. Now when you say the gold or the oil or water, so if you were on a desert island, which of those three would you want? I would say ultimately it's always trumped that the reason it hasn't been given the importance is that it's been cheap, available, and clean. When that changes, water, the way that we view water will change too.
Okay, I'm going to try and sound smart, which as a bartender is not easy, but I'll try.
The smartest people I know are bartenders.
All right, so this might be a tough question to both ask and answer, but here in northern Wisconsin, where I've only lived now for about 8 years, but we've had land up here for more than that, just south of here, and we've seen the water level on our lake continue to rise and fall, rise and fall. The last time it fell, of course, it's still continuing to rise, but it's not doing so at the same rate at what it was traditionally doing. I guess I'm wondering now if where we live in reference to you know, the continental divide and how much water we have coming in and how much is leaving as opposed to, you know, the ratio. You know, we obviously don't have as much coming in as what other people do because of where we live in reference to the continental divide. But are we blessed or are we cursed by that in reference to the water table?
Blessed.
Yeah. We're blessed.
Definitely blessed. Yeah,
okay.
you're in a part of the world that...
Well, I was a journalism major, so the shit always flew uphill. So.
Well, I will tell you an interesting fact of Europe versus the U.S. is that in Europe, that they would always go put their water intake on the downstream side of their town to make sure that their system was operating. In the U.S., we always make sure that the intake is up and the thing is a down. So I think there are some ways that, yes, it can go upstream, but not very often.
I have a follow-up to that question. Does surface water affect groundwater more, or does groundwater affect surface water more? How does that dynamic work?
That's a great question. The answer, again, like all good answers, is it depends. I mean, here where we are, most of the bank account is below ground. So the prevailing influence is groundwater has more of an effect on surface water in general across the board. That said, there are a lot of places where the surface water moves back into the groundwater and has a very big effect on the groundwater environment. And there are a lot of places where the surface water has a remarkable influence on the groundwater. And, and ultimately, to get water into the ground, it has to move, it has to cross across the surface and percolate into the ground. So that sort of puts a oh, sorry, Randy. Puts a fingerprint on it. But Randy's about to read a passage.
Yeah, I was going to say, spoken like a true surface water person. As a groundwater person, I'll just point out, scientific facts are, if you look at the water in the world, 97% is in the oceans and saline. 2% is in the ice caps and glaciers. Groundwater, 0.61% of the world's water. And oh, there's so many zeros with that surface water, I can't see. 0.0009% of the world's surface water. So if I looked at a global perspective, and me being a global citizen, I act local, but I think globally, I would say groundwater is by hands down the biggest, best thing you've got going for you up here. I would say, though, too, all joking aside, these are false distinctions, just like groundwater doesn't know political boundaries. Groundwater doesn't know whether it's surface water or not. It's all the same water. When you pump next to a river, you pull water, and that water is water. It was water that came from the stream, went through the ground, and is now in your well. It's a single resource. Your water is connected in so many ways that you can't see, that there is no use to really distinguish between them. Legally, we do it. For regulatory-wise, it's a means of dealing with it, but they're not different water.
So if I live on a little 27-acre lake, and the water level has risen in the past 2 years, so I definitely can conclude that the groundwater level has risen in order to see that lake level rise. Okay. Thank you.
I should say the great thing about to remember, even as Emily and I joke back and forth about this, for most of your lakes and your wetlands, the bulk of the water comes as precip. If you looked at their bank account, the most of the water comes in, and so all the systems see the effect of the drought, or they see the effect of really wet systems, but those are usually the biggest sources. Groundwater and surface water are kind of the fine-tuning that give you the really nice systems. Why a groundwater wetland, a fen, looks so different than a bog is the groundwater. But otherwise, the water is just water.
If people in California can pump enough water out of the ground to compact the ground and not allow water back in it, what does fracking do to the water above it? I mean, does it pull water down? What happens?
Yeah, that's. I wish this is a case where a visual might go a long way. The thing that people forget about groundwater is that the groundwater goes all the way down till the system has no pores anymore. The groundwater in the area that they're fracking, you don't want to drink. In fact, a lot of these fracking areas have high methane in the groundwater without fracking. And so that part of the groundwater system is very deep and very different than the shallow skin of the groundwater system, which is cheap and easy to access. Even though the well driller, his kid might need braces, but you're usually tapping the uppermost system because that's cost effective. So what happens down below is that it's separated by a lot of resistance. Now, some cases there'll be failures, engineering failures, and so just as you'll have a well seal, you'll have an E. coli show up in a local well because the casing water ran down the casing into a well. There'll be that kind of thing, but in general, the systems are so different, and the water resource of the fracking system is not a water resource that we are presently targeting for use. It's when they connect to a shallower system that it becomes a bigger deal. Water's all water.
I have a question. Okay. I don't know. I'm just curious. So with, sorry. So when I'm going back to where we decide we got to build this 3-story building on a wetlands, and so we're going to fill this all in and put a wetland somewhere else, like 10 miles away or something. Does the water remember that it used to be there under that 3-story building, and 100 years from now it's going to sink? Kind of like the Northwestern building in downtown Milwaukee, where they have to keep putting pylons in the bottom of it every couple of years because the thing is always sinking. And if any of you have ever seen this building, it's a block square. And so this program where we replace these wetlands elsewhere, do we know 100 years from now, or do you have a motto 100 years from now that this is just going to be all fine and dandy, it's not ever going to know it was a wetland once before?
Boy, that's a really good question. I would say that I have a model and it goes out 100 years, but the great thing about my model is I won't be here when that particular prediction is decided whether it was good or not. You do bring up a really good point, though, about wetlands that people forget, is that you ask to the road builder from the Wisconsin DOT, they hate putting a road through a wetland. The maintenance to go keep a road good, and you've seen this as you drive through a wetland and you get the washboards and everything going bad. It's really hard infrastructure to go maintain. So generally, the cost benefit of building on a wetland is almost always in the benefit, just go buy somewhere else that's not a wetland. So a lot of the wetland development that happened by a developer is usually not the 3-story building, but I have seen that happen. And in fact, I've helped the Department of Justice go after a case like that. It's ultimately comes down to that the wetland, humans are here on the earth, but the earth has been here a long time, and it'll be a long time after we're done. So that wetland is going to go, it's been here, it's ephemeral, the glaciers came through, wiped it out, they built up again, made their living, got wiped out by the glacier came again and again and again, and each time they rebuilt. So I think ultimately that as a geologist in the geologic time scale, very long time, that wetland does remember, it doesn't really care that much.
That's good to say.
This is a question that may be unrelated, but I've been asking it for 7 years. If you could have a tree that could do or be or create anything imaginable, what would you imagine? You could have a tree, a seed that could produce a tree that could create or do anything imaginable. What would you imagine?
Okay, I'm just going to go with an easy answer on this one. So I'll tell you before I answer it to say one of the things I like to study a lot is carbon and nitrogen cycling. I would like that tree to be a tree and take up a lot of carbon and store it for a very, very long period of time.
I thought from a Red Sox fan you might have got something different out of that, but I hope you grow to a bat that goes and knocks it right out of the park. You know, it's interesting because there is no magic bullet. These are trade-offs. These are, I guess I've tried to convey that over this evening, is that if the answers were all easy, we would do things. It would be pretty straightforward, and it would do. So it's the trade-offs that are hard. So to me, to say that a tree that it could do, there's a lot bigger problems, especially in Wisconsin, than the problems I've been talking about. And there's, I would say that there's a lot of things I'd like that tree to go do, but I'd have to think a lot harder if I only had one thing, what it would be.
I have another question, if that's all right. Going back to the wetlands, you know, we had the whole movement a century ago where wetlands were swamps and yucky and dirty and drain them and build them and all that. And I feel like maybe that tide is turning a little bit again, where we see their value in things, or maybe that's just the people I hang out with. I don't know. So where do you see that trend at this point in Wisconsin or nationwide?
Well, so it's not just the people you hang out with. It is the law that, in fact, wetlands should have legal status to be protected. And this is why if you drain one wetland, there has to be the mitigation or the mitigation bank to seek the goal of no net loss. Because I think you're absolutely right. In fact, when I give a lecture on wetlands, I like giving the quote about how wetlands were legally defined in the state at the turn of the century, which was they're places that you can only farm if you engineer them, to now being something quite different based on their actual physical, chemical, biological conditions. And it has come, we do realize many of the ecosystem services that wetlands provide as kidneys, as habitat for wildlife, and a broad range of other things that they provide. And I think because of the wetland protections that exist at the state levels and at the federal levels, that we are in fact doing a much better job of slowing the rate of wetland loss, of trying to stem the tide of making them disappear. And they are one of the great bulkheads of water quality protection. So while progress is never as fast as a lot of people would like it to be, we are, I think, absolutely moving in the right direction with protection.
Yeah, it's interesting because you say, because I know exactly what you mean. I mean, it was your civic duty to drain that wetland and make it productive back 100 years ago. But it was even 25 years ago at the same time that the DOT was paying me to help them mitigate wetland loss. Lobbyists were at the same public meeting that I'm presenting at saying, I remember when more food was better than less food. I remember when less mosquitoes was better than more mosquitoes. Have you all gone mad? And it's a different perspective, because it isn't so much wetlands or not as a abstract thought. It's the wetland that's keeping me from doing what I want to do on this landscape, which I view as a higher purpose. So it's ultimately that the question is about the wet, and this is what they have to wrestle with, because as a wetland scientist, I can tell you wetlands are not all the same. But on the other hand, how do you treat this person differently than this person when they both have a wetlands question? So the law tries to go treat wetlands as one entity, when there is actually no, I mean, you have 14 different kinds of wetlands in Wisconsin alone. We have over 100 in the U.S. These are very different systems, very different threats, very different resilience. And so the idea that we have one legal framework to go and answer, and the other thing is that it's always dynamic. The legal framework changes faster than the science can backfill. So what Emily says is true, and it was true for the bulk of the U.S. up until a Supreme Court decision that said that's only true for jurisdictional wetlands that are defined by navigable waterways. Navigable waterways are ones that, in Wisconsin, they were used for logging. Ones that they could float a log down. That was considered a navigable waterway. But if your wetland was not on that navigable waterway, it was not jurisdictional all of a sudden. Even though the previous 30 years it had been, all of a sudden it was not a jurisdictional wetland anymore. The state stepped in and said, well, we want them to monitor, but that's under a different law than the, so I actually have some sympathy for the people. If you try to get a wetlands fill permit, it's an incredibly tangled task, and so you're looking, I'm trying to do a greater good here. I have the village board appropriates, the Chamber of Commerce wants this. Why are you standing? And I would have to say the zoning administrator probably has the worst job in the entire world. Is you have an angry public that wants something, and you have a county board that wants the tax base. So I put in a plug for your zoning administrators, is that's a tough job.
Any other questions?
On that same note, how do you feel about the revised rule with the EPA regarding the Clean Water Act? changing from just the regulation, changing the regulation to include isolated wetlands?
Yeah, what you're saying from a wetlands and from a scientist, that was a Supreme Court decision that was not science-based. When they said there was a wetland that's isolated, what does isolated mean in a watershed? And the example they used was a borrow pit in an alluvial fill, a river valley of sand and gravel next to a river. And the lawyer said, there is no science that shows there's a connection between this wetland and the river. And the Supreme Court said, oh, well, how can we know that? When the rest of the science is going, of course we know that's true. That is the same water. It is exactly the same. So ultimately, we're dealing with, as scientists, we've had the second decision after that's called the Swank decision that pushes in the Rapanos decision, where then it was, we aren't sure what wetlands are, but they should have ducks. The idea that they should support wildfowl, and that actually comes from the it actually comes from a legal framework, as you would expect as Supreme Court judges, that makes the wetland produce of the wildfowl an interstate commerce entity. So then they have jurisdiction. And so that, I mean, it's not as bad as it sounds, but what I'm saying, these questions, when you're saying as a scientist, I say, I know there is no such thing as an isolated wetland. There is no such thing as an isolated wetland. A legal and jurisdictional, that's a different entity that is acting on those wetlands.
But do you think that this will be worse for these said isolated wetlands because now they will be under the jurisdiction of the Army Corps?
Yeah, I mean, right now they weren't, but they were, right? And in Wisconsin, after, I mean, Scott McCallum signed, we have an isolated wetland bill. So they are actually protected within the state. But that's through a water certification certificate that the state gives the Corps of Engineers. So it's kind of a very convoluted way, but none of these things are very easy. But in the state, the isolated wetlands were very only unprotected, unregulated for a very short amount of time. As far as I'm going to say, the idea, again, I don't know what the answers are. Regulation, I work for a government bureaucracy. Is this recorded? But I mean, the idea being a government bureaucracy has its share of rules and regulations, and that it is amazing. I could spend all my time keeping up on the rules and regulations. I don't know what is the right mix. I do know that there's a fair amount that everybody has to be treated the same way. And if there are no isolated wetlands, to me it makes sense that you would treat everybody the same way on the landscape. But that's an easy thing for scientists to say, very hard to go implement on the landscape.
Thank you so much, Dr. Emily Stanley and Dr. Randy Hunt. Fabulous night. And thank you all for coming tonight, and thank you from our partnership of the UW Trout Lake Station, UW Kemp Natural Resources Station, the Minocqua Public Library, the Lakeland Badger chapter of the Wisconsin Alumni Association, and especially our hosts, the Minocqua Brewing Company. Thank you very much. And don't forget, we have our next Science on Tap, January 7th, Scandinavians in Wisconsin. Thank you. Have a wonderful holiday. Thank you all for coming.